Hey again, Mr. Reeves here, and we're back to IXL. Now we're on 8th grade skill F13. Identify equivalent expressions involving exponents. Okay, so this is going to be similar to what we've been doing, except we're going to be matching, which sometimes makes it a little bit harder. You would think it'd be easier, like multiple choice. But the problem is sometimes you come up with an answer that is different than what they have, and that's where it can get a little tricky. All right, but I don't think this first one is going to be so tricky because what we have here is 9 to the 6th times 9 to the 7th. All right, and the bases are the same, and it's a multiplication problem, so we're going to add 6 plus 7 is 13. So we get 9 to the 13th, and I scan my choices, and I see there it is, that very last one. I submit it, and with great joy, it tells me that I am correct. Okay, this one right here is raising to a power. And you remember when we raise to a power, we multiply the exponents. So 8 to the 9th power to the 7th power is going to be 8 to the 9 times 7. And 9 times 7 is 63. So I get 8 to the 63rd power, which again, when I look at my choices, I see, wow, there it is. 8 to the 63rd power. Good work for me. All right. This one right here, again, I'm going to add the exponents. I see that that choice is there. All right. I'm wondering if it's going to get a little bit more difficult, how many of these more I should do, but I'll go ahead and do that one. All right. Okay, this one's the same. I'm going to go ahead and jump up to the next level. I was hoping they were going to give me a division one, but they did not. All right. However, this one does have a negative exponent. The bases are the same, so this is going to be 10 to the negative 6 plus 6, right? But negative 6 plus 6 is 0, so I get 10 to the 0 power. And remember, anything except 0 to the 0 power is 1. And a quick scan of my choices tells me that is the first one, and so I choose it. Excellent. Okay, right here, 6 to the 3rd times 6 to the 3rd. Once again, the bases are the same, and I get 6 to the 6th power. And then when I look here, wait, 6 to the 6th power, my bad. 6 plus 3 is not 6. It's 9. Okay, now we'll try this again. When I look here, I see that none of my choices are 6 to the 9th power. All right, clearly it's neither of these. This has a 9, a negative 9 on the bottom. This has a positive 9 on the bottom. We need to remember a reminder, okay, that when you have, say, 2 to the negative 3rd power, that's 1 over 2 to the positive 3rd power. All right? And if I have 1 over 2 to the negative 3rd power, that would be 2 to the 3rd power over 1. All right, so a negative exponent in the numerator. Remember, any integer or whole number power can be made into a fraction by putting it over 1. Any negative exponent up in the numerator becomes a positive exponent in the denominator, and any negative exponent in the denominator becomes a positive in the numerator. So what do I have here? I have a positive up top. I could put it over 1, which means on the bottom it's not positive, it's negative. Okay, so the one we're looking for is 1 over 6 to the negative 9 power. Okay, this one right here, I've got 5 to the 6th times 5 to the negative 4th. When I add those together, I get 5 to the 2nd power, right? And that choice is there, so we are in business. Okay, now this one is raising to a power, so again, when we raise to a power, we multiply, right? So I get 8 to the negative 54 power. When I look at these choices, okay, it's clearly not that one. It's clearly not that one. That one has a 54. That one has a 54. It's a negative 54 power, but this isn't on the bottom, is it? Again, I could put it over 1 if I wanted to. And a negative 54 on the top will become a positive on the bottom. Again, we're talking exponents, and a negative exponent on the top becomes a positive exponent on the bottom. So this was the choice we're looking for right there. Okay? Alrighty. Now, on this one, they've changed it up a little bit because now the bases are different, right? Okay. Now, if you watch my first version, not the video, the new video I made, but my original video I made for this, I messed up royally. All right, I made these really big numbers, and I tried to do it that way before I realized, yes, the bases are not the same, but the powers are. All right, and I actually talked about this, I did in the previous video, 12 to the 4th over 3 to the 4th. That's the same as 12 over 3 to the 4th power. Do you remember when we did this before, right? 12 over 3 to the 4th power would be 12 times 12 times 12 times 12 over 3 times 3 times 3 times 3, right? But do we know what 12 divided by 3 is, right? Order of operations, if you think of PEMDAS, right? It says to do what's inside the parentheses first. Well, if we do what's inside the parentheses first, we get 12 divided by 3, which is 4. And then we get 4 to the 4th power, which is much easier to work with than the big numbers we would have had otherwise. 4 times 4 is 16, times 4 is 64, times 4 is 256. All right, and that's the answer that we would have gotten if we were evaluating like we did in F12, but this is matching. I just wanted to remind us what we were doing, so let's see which of these it is. There it is, 4 to the 4th right here. Okay? All righty, similar deal here. We've got different bases, but the exponent is the same. So I can rewrite this as 10 over 5 to the 2nd power, right? But 10 divided by 5 is 2, and then I get 2 to the 2nd power. If we were evaluating, we'd say 4, but we're not. We're matching, and they have the power right here, 2 to the 2nd power. All right, same thing here, right? 12 divided by 3 is 4, right? They're both to the 2nd power, so we're going to get that one. All righty. And what about this one? Now we've got a power. We're raising to a power. So we get 5 to the negative 20th power. And you see that's not one of our choices. But 5 to the negative 20th power is 1 over 5 to the 20th power, which is also not one of our choices, right? This has a negative 20 on the bottom. This is supposed to be a positive 20. So let's just go through here. 5 to the negative 3 divided by 5 to the negative 3, that would be 1. This does not equal 1, so it's not that. We know it's supposed to be 5 to the positive 20. It's not, right? 1 over 5 is 1 over 5 to the 1st, so it can't be that one. So it's got to be this crazy looking one, all right? If you take a look at this right here, you have 10 to the negative 20 over 2 to the negative 20. Well, guess what that is? That's equal to 5 to the negative 20, right? Because once again, that would be 10 over 2 to the negative 20 power. All right, so that is the answer we were looking for, that last one. All right, let's go ahead and skip up to the very end and see what we've got here. Is it going to let us go to the challenge zone? Okay, here we go. We've got 8 to the 3rd times 8 to the negative 2nd, right? Now, that's going to be 8 to the 1st power. That's none of our choices, is it? 8 to the 1st power? Because all I did was 3 plus negative 2 and made it 1. Oh, wait. 8 is 8 to the 1st power. What am I thinking? That is our choice right there. What? They call this the challenge zone? My goodness gracious. All right. anything divided by itself is 1. Let me say that again. Anything divided by itself is 1. Okay, there is an exception. 0 divided by 0 you cannot do. Okay, you can't divide by 0. Anything else divided by itself is 1. Wow. And they want us to be challenged? What is this? All right, here we go. Multiplication, 5 to the negative 27, right? Is that one of our choices? No, this is 1 over 5 to the negative 27. Those are not the same thing. Clearly, it's not that. Clearly, it's not that. So it has to be this one. This is like that one we did just very previously, right? 10 divided by 2 to the negative 27 power, right? And so we get 5 to the negative 27 power is that. Alrighty, and we're just getting more of the same. So I'm just going to stop here. I hope, as I always say, that this was helpful to you. But never hesitate to ask for extra help. I'm always here for you. All right, until next time. See ya.